going to start this with an example that you should be able to solve for the most part, but then we're going to have to stop and I'm going to show you something. Let's say I gave you this, and I said to solve it. Go ahead and solve it and see what happens. Tell me what happened when you solved it. Got numbers? All right, we all agree that we did this, right? Yes. And we did, yes, that's what I wanted you to see. So I got negative 24. Why is that a bad thing? Why when I do this, why? Why can't I have a negative under the bracket? That's exactly right. The only way to get a negative is if you have a positive times a negative, and by definition, the square root is a number times itself twice. So it can't be different. So I can't do this right now until today when I say, and I introduce you to imaginary numbers.
Is it like your imaginary friends?
So P7. So P6 could have 37.
If I told you to let I, it's a variable, right? Let it represent the square root of negative 1. So instead of the square root of negative 24, let's think about this. Let's break it apart like we broke apart some things yesterday. And let's think square root negative 1, square root 24. Yes? Do you agree with that? Can I do that now? I could let I hold the place here, and I'd have square root of 24. I'm still plus or minus, and I can still break 24 up the same way I did yesterday. What are the two numbers? 4 and 6. Where did what? Okay, because the square root of 24.
What?
Okay. Square root of 6. Square root of 4 is 2, so 2 root 6. Yes, Palmer.
Wait, so if you have a negative number, the I is negative 1.
Yes. Right. Because I'm letting I be the square root of negative 1.
So you can have I as an answer.
There's the answer, plus or minus 2I root 6, except with the I. There's a couple other things, of course, that I'm going to throw in here that you have to be able to do. But as far as I goes, when you encounter a negative square root, okay, so that's the big explanation from it. In general, what you do when you encounter a negative square root is you take the negative out, you put an I on the outside, and then you finish the way you would any other time. Okay? No. A little bit, but it's not bad. Today's not bad. Tell me this. Do I need to do another example with I and the square root? It's pretty easy. What if, tell me this, if I is the square root of negative 1, what is this?
1. There's actually 1 because it represents negative 1. You multiply it, you know.
It's negative 1. Remember, if I square like this, these are opposite operations, right? So it's actually negative 1, okay? And I say that because what if I had 2I times, I don't know, 6I? 12I squared. And I squared is what? Okay. And let me show you what happens when you didn't like it. When we have i's with fractions, for example, if I had this, can I have that?
No.
Why?
Negative. It's I.
Not because a radical. It's a radical. It's the square root of negative 1. I can't have. So when you are dividing by imaginary. How do I get rid of it? How do I change it so that it's not an I in the bottom anymore? Multiply by I, because remember the rule with radicals is whatever that radical is, multiply that top and bottom, right? So here, the radical is square root of negative 1, which is just happens to be I, so I'm going to do that top and bottom. So I get 2I 5I squared, which is 2I over negative 5. Easy peasy? What if that number in the bottom was already negative? Then it would turn it positive. I squared essentially just changes the sign of the number. I squared changes the sign of the number. To show you complex numbers. I'm so glad, me too. So what we're going to do is we are going to add, subtract, multiply, and divide with complex numbers. So first you need to know what a complex number is, right? It's complex. It has two parts. It has a real number part, and then you either add or subtract an imaginary number part. So a complex number looks something like 2 plus 7I. Negative 5 plus 6I. 5 minus 8I. Any of those are complex numbers. As long as you start with a real number and you end with an imaginary number, it is a complex number. Okay? Just because there's an I doesn't mean it's imaginary, because obviously here that means it could be complex also, okay? But so if it's just a number with I, that's imaginary. If it's a real number and imaginary, then that is complex. Questions about that so far? Let's do some operations with them then. Addition. If I want to add complex numbers, so let's say everybody agrees that's a complex number? Everybody agrees that's a complex number? If I want to add them, what do you think I do? Yes, that is all you do. Combine like terms. Easy peasy. I was waiting. 2 and 6 is what? 3I and negative 10I. It is that easy. It smells good in here. Let's look at subtraction. Let's take those same two complex numbers. Remind me what they were. 2 plus... I'm going to subtract 6 minus 10i. All right, so subtracting is really, really similar to addition, and you guys should know how to do this. If I'm subtracting everything in this parentheses, that means essentially what I'm doing is distributing a negative 1 through, right? So you can do plus, you can do, I always tell everybody, same, change, and then change everything. Yeah. So you have to change everything in those parentheses that follow the minus sign, okay? So now it's an addition problem. Gather up your like terms. What's 2 and negative 6? What's 3i and 10i? Yeah. Now, unless y'all need any more help with that, I'm going to leave it there. And move on to multiplication and division, because they're a little bit harder. Multiplication. Oh, the answer? Negative 4 plus 13i. Let's say, same ones. 2 plus 3i. 6 minus 10i. This time I am multiplying, not adding or subtracting. How do you multiply two things like this? Yes. FOIL, distribute. You've been doing that. You have been doing that. 2 times 6 is 12. 2 times negative 10i is? Yep. Think about it like an x. Do it the same way you would if it was an x. 3i times 6 and 3i times negative 10i.
Squared.
Yes, squared. Now, here's where things get a little different. Because anytime I see an I squared, it changes the sign. So this is not negative 30i squared anymore. It's plus 30.
Wait.
Only I squared, yep. Yep. I squared, if I is the square root of negative 1, I squared is negative 1. So if I had negative 30i squared, that would mean I have negative 30 times negative 1, right? Which is positive 30. It essentially just changes the sign of the number. Yep, and some of you have already seen the real number portion is going to be 42. The imaginary portion would be negative 2. That's the answer. Good. It's really, even the multiplication is going to be, I mean, even the division is going to be.
Are there gonna be like any really big numbers?
This is about as big as it gets.
Oh, really?
Well, I mean,
Even then.
9s, 4s, 7s. I see a 14 coming up in your homework, but nothing like that you can't do. All right, let's do division. What plus 3? 12 and 30 gave me 42. I just combined like terms. All right, division. We've already talked about dividing by an imaginary, right? Then we just do I on top and bottom. But what if we're dividing by, and I'm gonna just do a harder example to start with because I think you'll be fine with it. What if, oh, let's do the same ones. Let's do the same ones we've been doing. That's kind of fun. 2 plus 3i over 6 minus 10i. Again, I can't have a radical in the bottom. But if you remember what we did when it was square roots in the bottom and we were adding or subtracting, and you do the same concept. So what are you multiplying by? 6 plus 10i. Okay? So this time, so we're going to multiply top and bottom by, what did we call it yesterday? The conjugate. So this time it's the complex conjugate since it's a complex number. Complex conjugate. So today we are rationalizing denominators by finding the complex conjugate. That sounds fancy, right? But it's really not hard. All right, so the bottom y'all said was 6 plus 10i. And I'm going to do it to both because I have to multiply the same thing top and bottom. Okay? Now I've set myself up for a FOIL. The hardest part about this is remembering when to do conjugate and when to do I. Yes, ma'am. Because by changing the sign, it's going to eliminate the radicals. It'll eliminate the I in the bottom.
Why don't you change the sign on the 6?
You only have to change the middle sign. If you change both signs, it won't eliminate the... It's the magic of the conjugate. Only the middle sign. Only the middle sign. All right, up top. 12 plus 20i. 18i plus 30i squared. These are by far the most involved. Don't do it.
We don't even change
Negative 30.
Wait.
But yes. 36. 60i minus 60i minus 100i squared. Oh, come on, y'all. It's not that bad. I'm going to change all my I squareds. Minus 30. Y'all finished it already? Plus 100. Up top, real numbers, 12 and negative 30 would give me negative 18. I was going, it's not 20, my brain's, oh. 38a, I. And then on the bottom, 136. See how those i's canceled nicely out? And I'm done. I could actually divide everything by 2. Let's do it. 15, 16, 17, 18, 19. 2, 8. Is that right? 50. No, wait. What am I doing? Ah! 60. I'm trying to push through and be done. All right.
So you can divide the 19 by, or the 38 by 2 and not have I.
Because technically it sits outside the radical. So yes, it's not under the radical. No.